Working through some examples of problems that involve friction. We got a sled with mass 22 kilograms pulled across level ground by a child who's applying a force of 110 newtons at 55 degrees above the horizontal. Coefficient of kinetic friction between the sled and the ground is 0.3. What's the magnitude of the sled's acceleration? So as always, we start drawing a diagram. Applied force 110 newtons at 55 degrees above the horizontal. We always have a gravitational force. There's a surface, so we have a normal force acting upward in this case, and there's a coefficient of friction, so we have friction. That will always oppose the object's motion. So we can write Newton's second law in each direction. In the vertical direction, we have normal force going upward. As you can see, we have gravitational force going downward, and then we have an applied force partially going upward. So we need a component of the applied force in that direction. In the vertical direction, since the sled is sliding across the level ground, then in the vertical direction there's no acceleration. So we can see that in this case the normal force is equal to gravitational force minus force applied sine theta. Then in the x direction, we have a component of the applied force and frictional force, which we know is mu k times normal force. And we just develop this expression for the normal force, so we can substitute that in. Force applied cosine theta minus mu k times mg minus force applied sine theta equals ma. So our acceleration is that expression right there. If we move the m to the other side, and then we can plug in numbers and get our answer for the acceleration. Our force applied is 110 cosine 55 minus mu k is 0.3 times 22 times 9.8 minus 110 sine 55 all over the mass, which is 22. If we punch all that in, we can get our acceleration. 110 cosine 55. There we go. Minus 0.3, 22, 9.8, minus 110 sine 55, parentheses, divided by 22. And we get an acceleration of about 1.16 meters per second squared. All right, that's that one. Now, number 28. A block with mass 2.5 kilograms sliding down an inclined plane, angled at 19 degrees above the horizontal. Coefficient of kinetic friction. Block initially at speed, blah, blah. How long does it take to travel? Okay. So if we have initial speed and we have a distance, and we want to find delta x, when we have v naught, or sorry, delta x, we want to find time. The missing variable is acceleration. So we're going to do a problem with Newton's second law to find the acceleration and plug that into a kinematic equation. So what forces are acting on this block? Well, we have gravity, normal, and friction. That's it. Right, and remember, when we have an inclined plane, we rotate our coordinate system. So we did the frictionless version the other day. This is now a case where we have friction. So in the y direction, we have normal force going out of the ramp, and then a component of gravity going into the ramp. So from the vertical direction, we learned that normal force is equal to mg cosine theta. And in the parallel to the ramp direction, we have a component of gravity acting down the ramp, and then we have friction acting up the ramp. And we can plug in numbers. We can substitute first. We learned that normal force is mg cosine theta And you may notice mass cancels out, so it doesn't actually matter that the mass of the block is 2.5 kilograms. And we can plug in numbers. 9.8 sine theta minus mu k, 0.21 times 9.8 times cosine 19 equals acceleration. Oops, I wrote sine theta. We know it's 19. So I should plug that in. So then we have 9.8 sine 19 minus 0.21 times 9.8 cosine 19. So that's our acceleration, 1.244. Guess I should have left a little bit more space here. We want to know how long does it take to travel 2.3 meters. We can use the time-dependent kinematic equation. We've got 2.3 meters. Initial speed is 0.5. One half that value we just got for acceleration times t. I'll store that as a, and then I can put it into my y. So then we can take this and plug it in. 2.3, move over to the other side, it's minus plus 0.5 x plus 0.5 times a x squared, calculate a 0. We get time is about equal to 1.56 seconds. Alright, I'll put a few more spaces there when I print out the note packet next time. Alright, now here's an example where we don't have any numbers, it's all algebraic. Box of mass m is pulled across the floor at a constant speed by a rope that is angled at theta above the horizontal. The rope has tension t. Find an expression for the coefficient of kinetic friction between the box and the floor in terms of mt, theta, and g. So, especially in the AP exam, when you see a problem like this, make sure your answer is in terms of those variables. Sometimes you'll be able to get an answer in terms of other things that aren't necessarily given in the problem, but don't give that as part of your answer. Also, make sure you use the variables given. If there's an m1, don't write it as just m, because you can lose points for that. So we have gravitation, normal force, tension at an angle theta, and kinetic friction. So in the y direction, we have normal up, gravity down, and a component of tension up. So we learn that normal force is equal to mg minus t sine theta. And then in the x direction, we have tension cosine theta minus mu k times normal force equals ma. In the x direction, well, since we're going across the floor at a constant speed, we know the acceleration in the x direction is 0. So then we just have t cosine theta minus mu k times this nasty expression mg minus t sine theta. 0, move that to the other side and divide, we get mu k equals t cosine theta divided by mg minus t sine theta. Now you might notice this is actually very similar to problem 27, just that we were solving for something different while acceleration was 0. The setup was very similar to what we did in 27. So if the tension in the rope decreased, what effect would that have on the magnitude of the frictional force? Well, the magnitude of the frictional force is mu k times mg minus t sine theta. So it's mg minus something. So if t gets smaller, mg minus t sine theta, what's going to happen? Well, that's going to increase, right? So that means that kinetic friction would increase. Yeah. And you should write that out in words. Yeah.